So you had mentioned at the start that a lot of the technologies that have applications from quantum dots are display technologies. So going into that, you and your company Nanosys have collaborated with companies such as Samsung and LG to tailor your quantum dots for various display products, which has given you insight into the engineering problems that come about with trying to apply quantum dots in this space. And so, what are those advantages that quantum dots provide compared to the current technologies that are available in this space, in the display product space?
Sure. So there are, I guess, three main subjects in which quantum dots really have an advantage in displays. So the first is about color, that quantum dots can emit in very, very specific wavelengths. And what that means is if you can combine a very specific blue, green, and red back together, you can recombine those to create a larger array of the colors that humans can perceive. So for example, older display technologies could actually only recreate about a third of what humans could perceive. And by being able to be more specific about the wavelengths that are the source of the light in your system, we can get a lot closer to reproducing what's actually in the environment that humans can see. So color tunability and specificity is the first application. The second is about brightness and efficiency. So natural light is actually quite bright compared to displays. You can actually tell that, right? If you ever tried to watch, I guess, television on a lower quality set in something with natural room light on, then it's really hard to see anything that's going on. Right. So being able to have brighter displays actually makes them more vivid and lifelike, and it's easier to see the colors when it's closer to what we're used to naturally perceiving. So quantum dots are good in this area in two applications. The first is that they're really efficient. It's actually possible to make these materials with nearly 100% efficiency at converting one wavelength of light to another. And the other is that they're pretty stable materials. So because they're inorganic crystals, they can handle a lot of cycles of absorption and re-emission without damage. And this is an advantage compared to organic molecules that often have some sort of photochemical breakdown if they go through too many absorption and emission cycles. And then I guess the third aspect of one of the advantages of quantum dots compared to other technologies is about clarity. So quantum dots respond really, really quickly. You can turn them on and off in billionths of a second. So it's a really fast absorption and emission cycle. And if you compare them to other materials like phosphors, those can be much, much slower. So those can be microseconds to even milliseconds, depending on the material that you're talking about. So it's actually, if you're talking about anything that's a high frame rate, you really need your materials to turn on and turn off as quickly as possible. Right. So there's actually an interesting example of this. If you look at some of the displays that are based on some of these slower emitting phosphors, if you watch a fast moving object, something like a soccer ball, you can actually see a leading blue edge and a trailing red edge that has to do with the response time of the red phosphor in the system.
Wow. No, I'm going to be on the lookout now. Like, I'm going to go have to watch like a football game or a soccer game, and like, I'm going to be staring 2 inches away from the screen. But that's incredible how like tight that timing has to be to really get that true perception of what's going on.
So you mentioned previously the display products can only get to 1/3 of what humans are able to perceive. You said we're much closer to that now. I was wondering, what could it get to with quantum dot display products in terms of like getting to that natural human perception?
Sure. So I guess there are a lot of different standards in color technology that are set by sort of international regulatory bodies. And with quantum dots, we can get to, I guess, very high 90% or close, not quite 100%, but high 90s of these regulatory standards. And I think we're constantly pushing the boundaries of this. I think if you're talking about recombining 3 specific wavelengths, there's always going to be a limit, but it's far greater than it's ever been before.